Today is day 15. We are halfway mark to the 30-day challenge that we have put for ourselves. In the today's day 15, we talk about an important object-oriented principle which is called as polymorphism. What is polymorphism? How and why it is interviewers' favorite? Let's try to talk about all of this in this video. Let's get started. Polymorphism. As you can see that polymorphism comprises of two terms. One is called as poly and another is called as morphism. In simple term, it means that which can take multiple forms. See, as I say that the object-oriented world is always inspired from the real world. In the real world itself, if you can go and see that we as an individual, we take different we behave differently in front of different one, right? For example, the way I behave in front of my teachers is different. The way I behave in front of my students is different. The way I behave in front of my girlfriend, my wife, my friend, everyone, I behave differently, correct? So when we as an individual, the same person when it goes in front of other person, their behavior depends on the context it is. The same thing applies here in the polymorphism. It says that how an object behaves in the different type of situations. So on a high level, if I go and talk about polymorphism, it's of two types. If I go and talk about polymorphism, it is of two types. The first type of the polymorphism is called as static or compile time polymorphism. And this we normally achieve with a concept called as method overloading. We'll see with an example, but just for now, when you have multiple methods in a class with the same name, but the different signatures, slightly different signatures, they are called as overloaded methods, right? And with that, we go and do the static or the compile time polymorphism, so which you achieve at the compile time. And the second type is called as dynamic or runtime polymorphism. And this I go and call it as method overriding. This I go and call it as method overriding. Method overriding means if there's a parent-child relationship, the same method which the parent has, the child also has in itself, I go and call it as the method overriding. So these are the two concepts. We'll try to talk about each of them in details, understanding first what method overloading is, then talk about method overriding, and understand both these types of polymorphism, static as well as dynamic polymorphism. Let's get started. So now let's get started with the very first type of the polymorphism, which is called the static or the compile time polymorphism. And this static and the compile time polymorphism, as already mentioned, is happening because of a concept called as method overloading. So this is a very interesting concept. Normally in the colleges, when the companies come, especially for the freshers and also for the experienced folks, this is a very commonly asked question, that what is method overloading? Now, if you try to decipher, most of the time the meaning of something is always hidden under the definition itself. Overloading means something which is overloaded. So method overloading means that when in a class, in the context of Java, if I go and say that if in a class, if there are more than multiple methods, when you have multiple methods, and what is the meaning of multiple methods? It means that more than one methods have the same name. When multiple methods have the same name, that typically is called as the method overloading. But when they have the same name, they should have some certain different characteristics. So what are those characteristics? So one of the silent features of method overloading is that, first of all, they have same name. That's number one. Number two is that they should have the different parameters. They should have the different parameters. So when I go and talk about different parameters, either there should be different numbers of parameters, number of params, that should be different, or their type should be different, right? That's number two. And the third type could be that the two methods could have the different return types. They could have the different return type. And these are the characteristics of the method overloading. So let's try to directly go to our code and try to see with the help of the code example itself. So let me go and open my Eclipse. Let me save this file. And since this is going to be a little more involved, so let me go and create a new package for this. So inside this, oops, let me go and create a new package. And let me go and call it as polymorphism. What are you going to call it? I'm going to call it as polymorphism. Fair enough. Cool. Let me go and close all these files. Save it. Save it. Let me go and define new file called as Java class, and let me go and call it as math util. Inside this math util method, I'm going to show you now that how the method overloading works. Let's say that I want to go and create a method for adding the numbers, right? So one of the definition could be say like something like this: int add, and I go and say that int a int b, and then I go and return a plus b. So right now I only have one method called as add. Now later on, let's say that I go and get another method where I go and if you go and copy this, and let me go and say that int, and let me go and add the number of parameters int c, and then I go and do this a plus b plus c. So if you see here, right, so if you see here on the screen right now, right, this method also has a name add, this method also has a name. Since multiple methods have the same name, I go and say that this is called as a method overloading. Now there could be two or more methods with the same name. So for example, further variations that we can go and do is I can go and define something called as double add, and then I go and say that double a and double b, and then again I go and return a plus b. So here in this case, you see that the number of the parameters type has also, the return type has also got changed. Fair enough. Am I clear till this point? Okay. Now let's say that I try to do something like this. Let's say that I want to go and say that int add, and then I go and pass int a comma long b. If I go and do this, I see that this type is different. Let me go and also first of all return something. Return a plus b. Right now it is long. It is giving me the error. Right. Why? Because when I go and add int and long, it will become int, and it is trying to return int. So let me go and change this to long. Right. And again, I am able to go and change it. So all these methods which you see here typically is an example of method overloading. So now what happens in the case of the method overloading? Let's say that example in this itself. If I go and define a method, let me go and call all this as static methods. Static int. If I go and define this method called as PSVM here, right? At the compile time itself, whenever I go and say that add, let's say that I go and say that add 5.2 comma 7.9. When I go and do this at the compile time itself, right, my system is aware that if I go and call this method, which method should be called? It should go and call this method. So at the compile time itself, I know that which method has to be called depending on what kind of parameters and arguments that you have in store itself. So even though all these methods have the same name called as add, all these methods have the same name called as add, But depending on what value that I'm going to get passed, I'm aware, I'm very clear that which method will be called. That's why called as a static polymorphism, because same name but different functionalities at the compile time also, and it's fixed. This is the example of static polymorphism. Now, since we have understood what a static polymorphism is, let's talk about the next topic, which is the interviewer's favorite, which is called as runtime polymorphism, or called as the dynamic or runtime polymorphism. Now, what is dynamic and the runtime polymorphism? Dynamic or the runtime polymorphism, to understand this better, we have to understand another concept called as method overriding. What is the method overriding? Method overriding happens in the case when there is an inheritance. So if there is a parent-child relationship, and let's say that they have a method m1 in the parent also, and the same method the child also defines m1 itself, then I go and say that method m1 has been overridden by the child. So for the runtime polymorphism to happen, I need to have first understand what is the method overriding, right? So for the method overriding to happen, right, method overriding, what are the conditions that has to be applied? First condition that has to be applied is there has to be a parent-child relationship. The first thing is that there has to be a parent-child relationship. Okay. And then in the case of the parent-child relationship, second point is child method should have same name. The child should have the same method name. It should have the same parameters, same parameter. And third one should be that it should have the same return type. These are the conditions that you have to go and satisfy, right? And thirdly says that, you know, the child method access level can't be more restrictive than parent. So in the case, let's say that the parent has certain restrictions set by the access modifier. In the case of the child method, it should not be more restrictive. Let's try to understand this with the help of an example. I think that will make things more clear. So if I go and open my Eclipse, and let me go and define another class called as an animal here. So what we go and do is inside this, we're going to find another class called as class animal. And then let's say that animal has a method called as public void eat, and I go and say that sys out animal is eating. Fair enough. So animal has a eat method, and let's go and define another class called as a dog. I go and say that class dog, and I go and say that extends animal. Now, if I have to go and override this method, I have to go and define this eat method inside this dog class also. So I go and say that public void eat, and then I go and say that sys out, and I go and say that dog is eating. I have something called as the dog is eating. So what you see here is the animal is the parent and the dog is the child, and animal also has a method called as eat, and the child also has a method called as eat. They have both same signatures, they have the similar level of the access modifiers. So I will go and say that dog has overridden the method eat which is present in the animal, and this here is a classic example of method overriding. Now, when I go and talk about the concept called as method overriding, it only applies to the objects. So normally a method which is static, and please keep this in mind because interviewer might confuse you with this question. A method which is static, which belongs to the class, they are never overridden. Only the instance methods or the objects methods are overridden. So right now, since this is an instance method, it's not static, so this could be overridden, and this is actually overridden. So now, since we have understood method overriding, let's talk about that what the polymorphism here means, or the runtime polymorphism, right? So if I go and save this, we're going to define another class called a class cat. Class cat extends animal, right? And I go and say that public void eat, and I go and that says out, and I go and say that cat is eating. Fair enough. So what the situation right now is, I have an animal. So I have the animal, and then I have dog, and then I have cat, and both of them has overridden the method eat because both of them eat differently. Like dog eats in a separate way and the cat eats in a separate way. So now let's go and define another class here called as zoo.java. So I'll come here and go and click to the new, and I go and click on the class, and I go and call it as zoo. And inside this zoo, let me go and define a method called as public static void main. So I go and say that public static void main string gs. Fair enough. And now let's go and say, let me go and say that animal a1 equals to new animal. Fair enough. I'm going to create the animal object. Let me go and say that dog d equals to new dog. Fair enough. So this is an object, and I can go and say that dog. Now here I know that since dog is an animal, can I say that since dog is an animal, I know that animal is the parent and dog belongs as a child of the animal. So I can say that every dog is an animal. Can I say this statement? Yes, every dog is set as an animal, because since every dog is an animal, the Java here allows us to say that to store this object in the animal itself. Fair enough. Now, can I say that every animal is a dog? The vice versa. Can I say that every animal is a dog? Can this statement be right? No, right? This will be false, because a cat could be also animal. Not every animal is a dog only, right? And that's why, for example, if I go and try to write here, I try to write the child here, dog, it will throw me an error. I cannot do this, right? Because not every animal is a dog. Few of the animals could be the cat also. So this has to be like animal only. So you can always represent a child object with the help of a reference variable which is pointing to the parent object, right? For example, this dog is a reference variable which is of the type animal, because, and it's ready to reference a dog object because animal is the parent of the dog. Same way I can do it for the cat also. So I can go and say that animal cat equals to new cat. So if you see here in this case, all these variables a1, dog or cat, all of them is of the type animal only. But when I go and execute this command, for example, if I go and execute this code which says that a1 dot eat, and then I go and say that dog dot eat, and then I go and say that cat dot eat, and I save this, can you guys guess what will happen? When I go and hit a1.8, since a1 references to this animal, whatever is the method inside this animal will get executed. When I go to dog.a, dog belongs to this dog object, so anything which is inside this dog object will get executed. If I go and say the cat.it, anything which is inside the cat object will get executed. Let's try to run this and see if that works. So let me go and run this. And as you can see here in the bottom, right, for the a.eat that I have animal is eating. For dog.eat, I have dog.eating. For cat.eat, I have cat.eating. So what you see here is that all this type a1, dog, cat, all is of the same type animal. All of them are executing the same method eat, but still at the runtime their behavior changes, and this is the excellent example of polymorphism, and this is called as a polymorphism at runtime. Again, this is a very important concept for you people. In the question, in the interview, if someone asks you this question, ideally you should write this small code, take this example to explain how the polymorphism is behaving here. Now, mastering the art of polymorphism helps first in the code better organization, and at the same time it will also help you to unnecessarily avoid writing too much of code. You can reuse a lot of code. Let's try to give you an example how it could be used to reuse the code. Let's say that I want to go and define a method called as feed animal, right? Let's say that I go and define a method called as public static void, and I go and say that feed animal. Now I know that there could be multiple types of the animals. Right now I have an animal like cat and dog. In the future it could be another one like donkey, tiger, and whatnot. Now if I have to go and keep on creating the individual methods for each of these animals, it will take me a lot of time. So if I go and make use of polymorphism, I can just say that this feed animal takes an animal as an argument, right? And I know that every animal will have a method called as eat. Now because of this thing, if I now have to go and feed things, I can just go and call feed animal, and then I go and pass a1. If I have to feed dog, I can just go and call the same method and call it as dog. If I have to go and feed cat, I can go and call the same method and go and call that feed cat. Right? I'm able to do this because at the runtime, this animal could be replaced by any of the objects. In the future, let's say that we end up creating the more objects, more animal objects, it can still be replaceable. Right? So this is the use of polymorphism. So with this, we have come to the end of the today's session. We have talked a lot many concepts. If you're not able to go through that in a one single sitting, you have missed something, please make sure that you watch it again, because today is going to be a super important concept for you, both for the interviews and also for everything that we're going to do going ahead in the Java and the data structures and follow up everything. So finally, we are done with the day 15 video as well. We are halfway down. We had this challenge of 30 days where every day you are getting a token of Java knowledge, which will help you get started in the journey of Java development, and if you want to do DSA in Java. We are half done. Today we talked about polymorphism. I hope you are having a great experience. However it is going, I would like to hear that views in the comment section so that we can improve, we can do better, and we can bring more amazing content for you people. Keep learning, and I'll see you in the next video, day 16.